So hello everyone. Today we will be solving this question 2 sum. So what does it state? Given an array of integers num and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So what we are given is an array. The first approach which comes into my mind to find a pair is a brute force approach, right? So what we can do here is we will run two for loops and just find the pair. So let's just see it in the code. We have calculated the size of array. Now we will run the for loops. So this for loop will gonna eventually return me a pair of two numbers, which will, when sum up, gonna give a target 9. If not, then we can just return -1 and -1. As it is not mentioned anywhere what we have to return if the solution we don't have a solution, but it has mentioned that it would have exactly one solution. So this condition will never gonna arise, but yeah. So how do we optimize this brute force approach? This brute force will gonna cost us O of n square O of n square time complexity. And here it is mentioned that can you come up with an algorithm that is less than O of n square time complexity? So here we will be using a data structure called map. So what we can do here is we can use an unordered map. So why unordered map? Because the search operation will gonna cost us O of one time complexity for the search operation, and whereas in ordered map it will be log n. So as we have to find a pair, right? So if we see in this explanation of this example, nums of 0 and nums of 1 is a solution and they are both adding up to 9. So what we can derive from here is to find nums of 0, what we can actually do is we can calculate target minus this element. So while iterating, we have one element with us, we have target with us. So we can just find the difference of that target minus nums of I. So once we have this difference, we have to just find if our map contains this element or not. If it does not contain, then we will add this element into our map. So as we have to return the indices of the number, so we are storing the index corresponding to the number in our map. So now if we find the number in our map, so what we will do is we will find not equal to okay, so what number we are finding is difference. So if we get the get the difference element in our map, then we can just return the stored number from the map using this. So as we have stored the corresponding index, so we are returning this index here, and this current element index will also be returned as a pair. So let's just understand this code with this example also. So while moving from, let's just write this example here, and we have a target of 9. So when we start iterating, first we have 2. So target minus 2. 9 minus 2 is 7. We find in our map if we have any 7 element or not. So no, we don't have it. So we will just enter this element into our map. And now we will go to the second number, 7. So when 7 is encountered, target is 9. 9 minus 7 is 2. So we got the element 2 in our map. So what we will do is return the index of 2 along with the current element 7. So as the solution is as we found the solution, we will just return because it has mentioned it will be having exactly one solution. So yeah, that's it. I will submit the code. So it is accepted with a runtime of 4 milliseconds and memory used is 14.38 MB. So let's just understand the time complexity of this code. So this for loop gonna take O of n, and this find operation gonna take O of 1 because we have used unordered map. And if we have used an ordered map, then it would have cost us log n. So it has saved time complexity. So it will be O of n. Time complexity will be O of n, and the space complexity will be O of n again because we are using an unordered map here. So yeah, that's it. Thank you.